Greetings! Today a set-top box to take apart. This one's a little bit unusual, it's not so popular one. This is BT Vision. So this is from BT Service Think Box, which you can connect to your internet and your aerial, and it will allow you to view all sorts of programs. It'll be interesting to have a look in this one because it's not so popular. It's not like Sky, for example. Sky boxes are notoriously available everywhere, car boot sales, flea markets, you name it. But this one, it's rather obscure because not so many people actually bought into BT Vision. So let's take it apart. There are a few controls on the front of the box, as you can see. That's probably the infrared receiver here, power, record button, and some backlighting light pipes, panels, a USB port. I'm just getting out of frame, the box is too big for my little bench. We've got USB ports and a viewing card port where you can insert your viewing card. On the back of it we've got power input, LAN network, USB in and out for the SCART connectors, HDMI, audio out, SP-Diff, S-Video, and antenna in and out for the aerial. They use the evil Torx security screws, the ones that have got a little pin in the middle, so just your average person hopefully is not in a possession of the right screwdriver, like here, and won't be able to take this apart. The screws are out, and I've noticed something while I was looking at it. Over here you can see a red cable, which for everything what I can make, it looks like serial ATA cable. That means there's going to be a serial ATA hard drive inside, which is good, because if it was the old type, that wouldn't be very good for anything apart from, you know, taking it out to bits completely. But this one possibly is still usable, so there we go. We are inside, and what we have is a separate power supply, with just like in many Sky boxes. We've got the card reader, we've got a heatsink, we'll have a look what's underneath, and this end here we've got a hard drive. It's a Seagate 160 gig, so not a huge one, but nonetheless 160 gig is better than no gigs. Let's take it apart a little bit more. The front should unclip with just those clips, I think, and there are clips on the side that also come off. There we go, and on the other side, and the whole front comes off. There is nothing in the panel itself apart from some light pipes, as you can see, and the little contraption that's molded out of one piece of plastic that just provides the buttons on the front. But then what we have is a nice array of switches, an LED, an infrared receiver. Those are really handy. That's out, so we'll put that to the side. It was just attached with connected by this ribbon cable, so that came off, and we can pull that in and disconnect it on the other end. We've also got one more screw for the USB over here. Okay, back on the top side, here is the USB. There we go, and it's a nice USB female end on a terminated cable, and that's quite handy. Could use that for something. Let's disconnect the power. Okay, let's put that to the side. There are a few more screws holding the different ports and whatnot on the back, so we'll unscrew those. And there is one screw from what I can see. Oh, there's another one here, so two screws that have to be unscrewed from the board. Nope, something's still holding it, so we're gonna have to take the hard drive out, and that is being held with those two, and there's two on the other side, so let's do that first. That's one of them. The hard drive is out, so we can just disconnect the connectors for the power and for the data. And we've got one more screw on the board over here. Set the hard drive to the side. We'll look at all that in more detail in a moment. Okay, the board still doesn't want to come out and it's being held over here. What I've noticed, those two metal pins are inserted after the board is in place, and those basically latch on the back. I haven't seen something like that before. So basically on this end you can see it's in between the plastic. There is those pins protruding on the other side. So I'm going to try to push them back in. There we go. And that makes the whole thing come out. Oh, one more screw. And the board is free. Okay, let's remove those two clips that are holding the heatsink in place that's sitting on top of the big chip. And then we'll have a closer look at the board and see what sort of magic electronics are happening in here. And that should reveal the chip. Oh, beautiful green Broadcom chip. So nice heatsink. That could be reused for something. Anodized aluminium. Okay. Alcohol just doesn't want to remove everything. Let's try something a little bit more aggressive. This should do it. So just a tiny bit and works the treat. So let's look at the board a little bit closer. And this is the connector that was leading to the front panel. And here we have a chip, LVC0788, mind you, it's upside down. But this is a hex buffer, open drain hex buffer, so basically a lot of MOSFET transistors, FETs that drive all the LEDs and whatnot on the front panel. And that's how they are doing it here, because the chips, the processors and whatnot, those are not capable of sinking that much current. Moving on over here, this is the power connector that was coming in from the power supply, and right next to it, no surprise, we've got some inductors, some capacitors right next to it, and we've got a chip PS5124, and this is just a buck converter. I've looked this up just a moment ago, and that steps down a couple of more voltages because all the interesting chips over here probably run at really low, 3.3 or even less. So moving on, we've got, well, that's memory for the main chip, and here we have STV6417, and that's another interesting chip, a bit of a relic because what it does, it's basically a switch for video and audio signals, all standard definition, and this basically is connected to the SCART sockets, and that does all the switching between inputs and outputs and mixing and volume control and that sort of thing. So yeah, this is old stuff, all standard definition, no HD. And moving on here, this is the money shot. This is what the brains of the whole unit. Broadcom BCM7405DQKFEBB01G, and that is a mouthful. What it is a dual core processor with all sorts of MPEG encoding, decoding and all that sort of thing, purposely built for set-top boxes. What's interesting that I haven't seen that before, it's got a green tint to it. Normally chips at the back of the die, like you see over here, normally there would be the blue or purple or that sort of shade, but this silicon is green, which is quite pretty. Moving on, we've got a weird chip over here called Spansion GL128P90FFSS7, and after a quick search on Google I wasn't able to find out what it is. Couldn't be bothered to waste more time on it, but yeah, once the websites take me all to all the broker sites where they try to sell you whatever that is. They will tell you that yes, we can make it for you, just buy 1,000 pieces or 10,000, but none of them has got actual datasheet to download. And here we've got not one but actually two identical chips, and those are TDA 10048NH, and those are decoders for digital video broadcast terrestrial, so DVB-T, and there's two of them here, so it can do two things at the same time. And yeah, it's a nice this is a nice solution, all in one chip, so that's all the magic over here. Here, that's a boring end, that's just a fan connector. There is quite a bit more power supply happening here, filtering rather, and that's right next to the power connector for the hard drive. And no wonder, motor in the hard drive can be quite a bit noisy. And we've got the serial ATA connector. It's a little bit closer so it's not focusing. And crystal, what frequency is that? 54 megahertz. And some capacitors to accompany the crystal. And the main chip, the Broadcom. Now it's quite interesting when you look at PCB. Over here you've got very distinct pairs. Those are differential pairs of signal going through, and you might wonder what those are. So that goes all the way down to the board, the bottom of the board or one end of it, and disappears in this can. And what it is, it's a USB connector. So it's really important that, you know, USB you cannot just hook up with two random wires. It's just much too fast for it. The data flow is too quick, and that's not going to work. The cable's got to be shielded, and if it's cable, it's twisted pairs in a certain way. And if those are tracks on PCB, you've got to do them like this, so they're exactly the same length and whatnot, and you know, all that sort of thing. There is a whole subject of to this. Now you can see more of those pairs going out right here. So 4 other pairs going out, and where are they going? Well, that's the HDMI, so that's another high-speed digital interface. And yet again we've got multiple controlled impedance, controlled length tracks, differential pairs going through. And this one is just video tracks. So this is just video signal going out to a video amp, and that's going to go into the cans and into the output. And yeah, you can see those tracks are significantly thicker, and they are single, so there's only one track per sort of channel or line. But with the differential pairs, you've got always 2 of them, and there's always you know, opposite of the signal going through one of the tracks. So you can take the differential reading at the end, and it gives you more room for error and decreases the noise and all that. So that's why you use and how you use differential pairs. And here we've got some connections. What else can we find? Oh, all those snaky tracks, that's again for controlled impedance. This is going to the memory, so clearly this data here is going to be rocketing through. It's really fast, and that's why again, some of the tracks might be longer at those sort of speed. It's the hundreds of megahertz. The difference of a couple of millimeters of the track can make a difference, and that's why sometimes you will snake a track through all the way back and forwards in order to make the signal arrive at just the right time on the other end. And here is more of that happening. It's quite amusing to see what's on those what's happening with those tracks, and a lot of them disappear in vias in some of the inner layers of the board. And what else have we got here? I think that's it. On the back of the board there is only one chip. Let me try to focus on it. There we go, that's the only chip on the back of the board. TDA8024TT, and this is a smart card from NXP smart card controller. So this is what's reading off and writing data to your subscription card on the service. And sorry, there is two more chips. They're just modules or memory modules. And we've got those cans. Let me zoom out a bit. Oh, there we go. We've got those cans that do some sort of RFy thing. Let's actually cut them off and see what's underneath. And under the cans, two same chips. So let's zoom in a little bit. Those are TDA18211HD, and those are from NXP. Both of them are the same chip, and those are integrated tuners for digital video broadcast terrestrial. So all of that is all the magic is happening in those, the whole front end RF. But what I've noticed, those cans, you could see those cutouts before, and it looks like they were designed with those little tabs that were left. They were designed to enter them this way if you had to. I'm not sure if they were designed that way, but it was quite easy to get into them that way. And what's another thing I've noticed, quite a lot of NXP chips over here. So this is NXP, this is NXP solder. It seems like NXP/Philips has made the majority of the stuff over here, apart from the Broadcom main chip. But anyways, let's look at the green die over here. So that's it for the board. Let's see what else is on here. Here is the power supply, and the power supply is made by Light-On. So that's interesting. At least it's got Light-On markings on it, so it's fair to assume it's made by Light-On. And looking at the bottom of the board, there is a very clear isolation between primary and secondary, or primary and secondary rather. And we've got opto-isolation coupling, a cap across the primary and secondary, the transformer that looks okay. We've got the common mode choke, some class X capacitors, X2, a fuse, quite a nice one, and a cap, 68 microfarads, 400 volts, was the brand. LTEC brand caps, 24th week of 2010 date code. And look, it's nicely that they marked all the voltages on here, and this basically puts out 12 volts and 5 volts. So it's a nice power supply module that can be used with something else. Presumably it will put out a few amps. An interesting thing is here. So we've got, you don't often see this sort of symbol, like two diodes facing into one another. And what this is a Schottky barrier diode. The hard drive is a Seagate 160 gig serial ATA, which is good. Just a hard drive, rather small capacity, but okay, that will do. And it's actually got a nice Molex connector on here that incorporates both the serial ATA and power. That's quite nice. They're not two separate connectors. It's just all molded into one plastic, and that fits nicely onto, backwards, onto the hard drive. There we go. Click, and it's, of course, it is Molex brand. Got the Molex logo on here, and this is made by Molex as well. They actually dominate the market for all those hard drive connectors and whatnot. The front board, this is just in contrast to the main PCB. This is done on the really cheap material. This is just a paper resin thing PCB. just cheap, but that will do. There's nothing special happening here. Single-sided, they found it was cheaper to put all those jumper links across all the board than invest in a two-sided PCB, which sometimes works. What's on here? We've got 1, 2, 3 dual color LEDs, which if you wanted to, you can desolder and use them in a little project. A whole bunch of buttons, one single color LED, yeah, it's a single one, and the infrared receiver, which sometimes you can reuse them. They're actually easy to reuse. They beautiful thing about this, you don't have to worry about any of the modulation for the infrared and whatnot. This basically outputs simple data, 5 volts, whatever it sees in terms of if it receives the infrared at the right frequency, it will output high or low, and just streams the data out whatever it sees. So they're quite easy and simple to use. Thank you very much for watching. If you enjoyed it, give me a thumbs up, and please subscribe for more random stuff that I'll be doing. And for the time being, take care.